So no joke tonight. We're just going to get right down to what we need to do. So today in class we talked about this equilibrium of water, and water had this equilibrium constant, H plus and OH minus. Notice that these are the concentrations or the molarities. And I told you that this KEQ, same thing as KW, and it always equals number. So now we have this equation. We have 1 times 10 to the negative 14th equals the concentration of hydrogen times the concentration of hydroxide. What we're going to do in the next two examples is I'm going to give you one of the variables, and you're going to have to find the other. And then I'm just going to give you the other variable, and you're going to have to find the first one. So they're very simple algebra problems. So you can just continue like right where you left off, right down here. But I'm going to start a new page just because I've run out of room. So the example is going to say find OH minus given the concentration of H plus. And remembering that the brackets, once again, those mean molarity. Okay, that's concentration. And I still didn't update that, so remind me, that's the point. So let's say that the concentration of H plus equals 9 times 10 to the negative 9th molar. And I want you to find the concentration of hydroxide. Okay, well we have this great formula that we just wrote down above. I did it for our purposes. So we have 1 times 10 to the negative 14th equals the concentration of hydrogen times the concentration of hydroxide. Okay, so if I am given hydrogen, I can plug that in here, and then I can solve for OH minus, and that's what I'm going to do. Very simple. So I say 1 times 10 to the negative 14th equals, they give me my concentration of hydrogen, equals 9 times 10 to the negative 9th, times my concentration of hydroxide. And I want to find my concentration of hydroxide, so I'm just going to circle this guy because that's what I'm trying to solve for. So I divide each side by 9 times 10 to the negative 9th. That cancels out. Now, you need to make sure when typing this into your calculator, you do input the parentheses. So let me show you how I do this. So I'd say 1 times 10 raised to the negative 14th, okay, divided by, open parentheses, 9 times 10 raised to the negative 9th, close parentheses. And I get this number here, and guess what? We're giving everything in this chapter 3 sig figs. Okay, so this is going to be my answer. So my concentration of hydroxide equals 1.11 times 10 to the negative 6. And it is molarity, because that's what these brackets mean. They mean concentration. So once again, I have this very simple formula. It looks complicated, but really it's as simple as something like 5 equals A times B. It's a very simple formula. Okay? It just looks complicated. And they give me one thing. They gave me hydrogen, so I plugged hydrogen in, and I solved for hydroxide by dividing it, and I get my answer. Now we're going to do one more example of this type of problem. And I'm going to say find the concentration of H plus given the concentration of OH minus. So I'm going to say that the concentration of OH minus equals 4.6 times 10 to the negative 7th molar, comma, the concentration of H plus equals, we don't know. Well, we've got this formula, and it is 1 times 10 to the negative 14th equals the concentration of hydrogen times the concentration of hydroxide. And all I need to do is I'm going to plug in what they gave me. So I'm going to plug in the 4.6 into the hydroxide. 1 times 10 to the negative 14th equals the concentration of hydrogen times the concentration of hydroxide, which we actually know is 4.6 times 10 to the negative 7th. So if I want to solve for hydrogen, that just means I'm going to divide by 4.6 times 10 to the negative 7th on each side. Very, very simple algebra, nothing too tricky here. The only thing that's really tricky is making sure you type it into your calculator correctly. So I say 1 times 10 raised to the negative 14th divided by, open parentheses, let me turn the light on, open parentheses, type in bond number 4.6 times 10 raised to the negative 7th, close parentheses. This is what my calculator spits out. We're going to give everything 3 sig figs, so my final answer is the concentration of hydrogen equals 2.17 times 10 to the negative 8, and the units are molar. Okay, so they're very simple. If they give you one, you can easily find the second one. Very simple. So let's move on to the next set of problems, and that is going to be calculating pH from the concentration of H+. So this idea of pH, we can actually find the pH if we know how strong the hydrogen ion concentration is. If we know the number, the molarity of hydrogen, we can get the pH from that. And there's this simple equation, and that is pH equals the negative log of H+. I'm going to box my equation. That way it sort of sticks out in my notes. And we're just going to do 2 examples. So let's say the concentration of H+ equals 7.2 times 10 to the negative 3. And they want me to find the pH. So all I do is I'm going to say that the pH equals the negative log of H+. H+ is this number, and if I take the negative log of this number, then I'll get the pH. 7.2 times 10 to the negative 3. So this is how you work it with my calculator. So I would put negative log, open parenthesis, 7.2 times 10 raised to the negative 3rd, close parenthesis. And there's my pH. The pH is 2.14. Okay, if you have a calculator like this with only one line of display, what you're going to do is you're going to type in the H+ first, 7.2 times 10 raised to the negative 3. Okay, once you have that in there, then you hit log. Oh heavens, that didn't work. 7.2 times 10 raised to the 3 negative. There we go. And then you hit log. And notice it gives you a negative 2.14. Since it's negative log, you just make that a positive. But we'll talk about that more tomorrow. Let's do one more example of this. The concentration of H+ equals 3.1 times 10 to the negative 11th. So, and they want me to find the pH. I just use this very simple formula. So, and that is pH is going to be the negative log of my concentration of hydrogen, which is 3.1 times 10 to the negative 11th. So typing this into my calculator, I would hit negative log, if you have 2 lines of display, negative log, open parenthesis, 3.1 times 10 raised to the negative 11th, close parenthesis, and I get 10.5. If you have a calculator with only one line of display, you would type in the number first, 3.1 times 10 raised to the negative 11th, 11 negative, hit equals, and then hit your log button because you're taking the log of that number. Notice it spits out a negative 10.5, but since it's negative here, you just make it positive, so it's a positive 10.5. Let's see, how are we on time? Perfect. Okay, and we're just going to go backwards now a little bit, or do the hydroxide. It's going to be the same exact thing, so if that made sense even a little bit, this next part will make sense too. Calculating POH from the concentration of OH minus. It's the exact same thing as pH. POH equals the negative log of OH minus. I'm just going to do two examples. Let's say the concentration of hydroxide is equal to 7.5 times 10 to the negative fourth, and they want me to find what's known as the POH, the hydroxide ion potential. So all I do is I follow the formula. I just take the negative log of my concentration of hydrogen, find out what I get. So I hit negative log of, open parenthesis, 7.5 times 10 raised to the negative fourth, close parenthesis, and my POH is 3.12. If you have a calculator like this, you would type in the number first. So I type in my concentration of hydroxide, which is 7.5 times 10 raised to the 4 negative. Okay, and once I have that number in there, then I can go ahead and hit my logarithm. So I take the log of that number. Notice it spits out a negative number, but since the formula is negative here, I just make it positive, and my POH is 3.12. So just backtracking, I've got this simple formula. If they give me one concentration, I can find another. And then, if I have the concentration of hydrogen, I can use this formula to find what the pH is. And last but not least, if I have my concentration of hydroxide, I can use this formula to figure out what the POH is. And we'll talk about this more tomorrow. I forgot one thing. I need to box this equation. Okay? Make sure you do 19.3 and have a great evening, guys. Garvin, out.